Good afternoon, everyone. I'm Deepak. I'm from Microsoft. I'm joined by David Harmon from AMD. Today, we're going to talk about what happens when confidential computing leaves the cloud and moves closer to where the data is generated, utilized, and where there's increasing regulatory demands for workloads to remain on premises, and a lot of use of AI is being done on premises. Confidential VMs have become a proven pattern in public cloud. The question we're exploring is, how do we bring that trust model to sovereign environments, edge deployments, factories, hospitals, retail locations, and even disconnected sites? That's where AMD SEV and Azure Local come together. With that, I'll hand over to David to kick us off.
Thank you, Deepak. Everybody hear me all right? Perfect, good deal, welcome. You're not going to hear anything new from me today. Everything that's from the keynotes to the different sessions that I've heard, it's awesome to hear the confidential compute conversation continue on. At the end of the day, what AMD has done specifically with Azure Local here is what we've done in the cloud. I mean, right now, I think we are the #1 geo with Azure, specifically confidential VMs, geographically positioned globally. That same solution that we've done on AMD SEV, otherwise SEV, secure encrypted virtualization, we're taking that into an Azure Local perspective. Trust but verify. This is that environment to trust but verify on the Azure Local side, the same pretty much product that you're getting in cloud specifically with Azure. You know, not all workloads are ready. We've heard about this for years, even before confidential VMs came in place. Standard VMs in a cloud environment, couldn't trust that operator, couldn't trust it, couldn't bring it. CTOs were like, no way, this stays here. This adds that level of protection on-prem still, and still then creates this hybrid environment back and forth. Is it perfect right now? That's what this environment and this consortium in this conference is all about. And the problems that AMD is resolving specifically with Azure Local is just one of those. So why is this urgent now? Like I said, you're not going to learn anything new from me here from this specifically, other than AMD and SEV and Azure Local for an on-prem solution is going to be there for you. AI is everywhere. I have to admit, keeping up with AI is insane. Insane, especially as CPUs. You know, we turn these things out every 2 to 3 years. All the P-certs that come along with it, we've got to be very quick with it as much as possible and make sure that that foundation that we're creating is solid from the beginning, because it's going to last a long time in these confidential environments. Obviously, anybody heard the word sovereignty today? Anybody? I doubt it, maybe. It's either sovereignty or AI, so one of those two buzzwords, one way or the other. Ultimately, we're solving those problems. We're making sure that that environment is, as completely protected as possible, that you can trust it and verify it either on-prem or in the cloud, and specifically with Azure Local, you can do it on-prem. And then, rising cost, CPU, GPU aspects of things. Not all AI has to be done on GPU, even though AMD has both. And the majority of the technology with our EPYC-based solution of confidential solution is EPYC-based at this point in time. Our roadmap, as you will see today and moving forward, and even as Hugo mentioned, our MI455 product in the future, as well as our Advancing AI event later on in July, you're going to see a lot of additional technology coming out to help with the distribution and those costs as far as that infrastructure. So AMD helped make CVMs real at cloud scale. We did this specifically with Azure. Hugo mentioned 2017. I'd say it's a little bit before then. We were working on AMD EPYC for our 7000 series, otherwise known as Naples. That was our first generation of SEV activities. And since then, we've gone from a single instance in Azure to multiple generations in Azure. And a lot of that, all we're doing here is complementing everything from a confidential VM aspect of things from cloud to the edge with the Azure Local. Next one. So cloud scale to local deployment, just like I've said for everything, trust but verify. If you've got an application that CVM makes the mark in cloud, you've got that opportunity specifically within Azure. If you don't, and you still want it on-prem, that's where Azure Local and the AMD SEV story comes into play. AMD SEV, we've got, it's kind of a layer cake. Our first generation was just secure encrypted virtualization, secure encrypted virtualization, then we went to an encrypted state, and then secure nested paging. Nested paging is kind of that level set that for the most part, that the majority of the security requirements are being met. And that's when our Milan or our Epic 9000 series, ever since beyond that, any one of those parts from an S&P part can have Azure Local confidential perspective. And we're working on next generation stuff too for that local deployment. So nothing new here. Why silicon matters? It's that foundational component. Adding with the Azure Local and the stack really bringing you to that confidential VM environment.
Right. Thank you, David. We've seen how AMD SEV established the hardware isolation foundation. But now let's discuss when we take that capability outside of a hyperscale data center, when that infrastructure is being operated by the customer, it brings in a lot more complexity to achieve an end-to-end confidential compute. Azure Local, and I need to give you a little bit of an introduction to what Azure Local is before we jump into how we're doing confidential compute in Azure Local. So I'll do that in a few slides. Azure Local is Microsoft's platform for delivering cloud-consistent infrastructure in customer-controlled environments. Whether that environment is a data center, an edge location, or a sovereign deployment, the goal is consistent operations, consistent security, and consistent management. A simple way to think about Azure Local is that it brings Azure operating models to outside Azure regions, to locations outside Azure regions. Customers that get familiar with Azure APIs, management experiences, automation tools, and security services, now they can run VMs, containers, AI workloads, virtual desktops in their own location. That's what Azure Local achieves. So this slide shows the breadth of the Azure Local platform. Azure Local provides core infrastructure services, Kubernetes, virtual machines, AI-ready capabilities, data services, management tooling, monitoring, and security. The takeaway isn't that there are many boxes on this slide. The takeaway is that local infrastructure no longer needs to be an isolated island. You can operate it and management in a consistent way, the same way you manage your cloud operational workloads. One point I'd like to emphasize is that local does not mean lesser. Historically, moving from public cloud meant making sacrifices around the functionality, security, visibility, or operational consistency. Azure Local is designed so customers can address sovereignty and risk management requirements without giving up the capabilities that they expect from their modern cloud infrastructure. This slide is a very important slide because Azure Local can operate connected to Azure, but it can also operate fully disconnected. For many organizations, disconnected operation isn't a special case. It is a requirement. What's important is that security guarantees we're going to discuss don't depend on continuous connectivity. The trust model needs to remain intact even when the network connection is gone. Underneath all of Azure Local is validated infrastructure. This allows us to provide a consistent and high-quality experience for our customers when they're operating Azure Local at scale. Architecturally, Azure Local is built on certified hardware from OEM partners, integrated with Azure control planes, Azure Arc Services, Hyper-V storage services, storage spaces direct, and optional SAN. The headline for this audience is that this is designed as a deployable, supportable platform with modern operational tooling. And security is fundamental to Azure Local. We built it on a layered security architecture. Security begins in silicon, extends through the firmware and operating system, and confidential compute sits at the heart of this model because it protects the workload data while it's actively being processed. So now let's take a look at what it takes to make confidential VMs trustworthy on Azure Local. When people think of confidential computing, they think about encrypted memory. Of course, that's the foundational piece coming from the hardware AMD SEV. That's necessary, but isn't sufficient. If we're going to deploy confidential VMs in customer control environments, we need more than isolation. Azure Local augments that model in 4 ways. Secure provisioning, so the host doesn't gain access to CVM config or credentials. Protection and attestation of CVM OS disk integrity, binding the V2PM root of trust to the TE hardware, and providing verifiable protection of data in use. So the story is not just encrypted memory, it is an operationally trustworthy CVM lifecycle. That's what we want to build into, that we are building into Azure Local. So let's look at each of these stages. At the first stage is sort of like what I call as the build stage, where you're building your guest OS. At this time, we need the OS image to start with integrity. The trust story begins even before the VM is ever created. We build an immutable operating system image using a read-only file system and dmverity. Utilizing dmverity, a single root hash that represents the expected state of the entire operating system is captured. This root hash becomes our cryptographic anchor, and if someone attempts to modify the file system, the hash is no longer matched. This gives us a verifiable representation of what the operating system should look like before the workload even starts running. This matters because it changes the question from, can I trust this disk, to can I verify that what booted matches the exact disk state that I intended? And that's a fundamental shift, and that's sort of like one of your thesis for like what the marketing term of zero trust. But here, by tying it to the OS integrity measurement, we're able to bind that, make that true. So once you've built that OS disk with integrity, next you need to bind that integrity information during your boot cycle. So the next step is to bind that integrity information into an industry standard like measured boot. So we use trusted platform measurements to capture the state of the system as it starts. There are many PCRs that are utilized. I'll touch on 2. PCR 4 measures the boot path and the execution components. PCR 11 measures information within the unified kernel image, including the kernel command line. Importantly, the dmverity root hash is captured as a part of these measurements. For the astute listener here, you might make a note that if we did not include the root hash, then there is no binding between the UKI measurements and the actual hash. But by doing that, the expected state of the operating system becomes cryptographically linked to the attestation evidence. In other words, the system can prove not only that it booted, but exactly what it booted. So now we complete that entire story. We have build time integrity, we have boot time measurements, but we also need runtime enforcement. At runtime, every block read from the operating system is verified through dmverity. If tampering occurs, the verification fails. But there's another critical element here, the external validation. Before secrets are released or sensitive workloads are trusted and loaded, an external relying party can evaluate the attestation evidence and make a trust decision. This is an important shift in thinking. Security isn't based on trusting that the system is healthy. Security is based on cryptographic evidence that the system is actually healthy. That's ultimately what allows confidential workloads to operate safely in a distributed environment. And stitching all of these things together is, I think you can call it sort of like the zero trust approach. Now, what we've done on Azure Local is this model remains aligned with confidential computing model customers already know and utilize in the Azure Cloud. Customers don't need an entirely different security architecture for local deployment. The same concepts of attestation, trusted execution environments, policy decisions, and key release continue to apply. And we're extending the cloud model rather than inventing a new one. Enough of talk. Let me actually show you a quick demo of all of this working together. Oops. So this is an application that we built, a sample application that we built. It loads only in trusted VMs. You can provide it an AI model URL. Here we'll go get something from Hugging Face. And then next we'll also supply it with some sensitive health data. Both of these are not yet loaded into the VM. And the application, the workload is performing, going to initiate an attestation. What we're just showing you is that there are no files in that location, so the model or the data has not been downloaded. So once you run the attestation, all of that operation that I mentioned before occurs. You can see all the PCRs, PCR4, PCR11, etc., which take those measurements, verify the OS disk integrity, etc., are captured here. And then we also compose all of that into a unified message or composite attestation, which shows it as SEV SMP from AMD, and then it's also an edge compliant CVM. That stitches all of this together, and of course the specific the AMD EPYC chip, the Genova silicon chip, and that shows the attestation completed. So that shows the attestation is successfully completed, and as a result, the workload then goes ahead and completes the operation of downloading those sensitive data in the AI model. In a future presentation, I'll also show you how we use a relying party to obtain the key to decrypt the AI model and decrypt the sensitive data that we just downloaded. So even though the data is downloaded, it's still stored in an encrypted manner, and it's extremely important that the decision-making occurs outside of the CVM itself, using some sort of a trusted relying party that exists outside of the CVM. And that is necessary to sort of maintain the full integrity and protection of the data that runs inside a CVM, especially on premises. With that, let's go to, we're right on time in terms of closing. So making local CVMs deployable starts with AMD providing a trusted hardware isolation foundation. Azure Local extends that foundation with secure provisioning, operating system integrity protections, attestation, and CVM lifecycle management. The result is a confidential VM that is not only secure in theory, but deployable in environments where customers actually need it and where customers operate the infrastructure. Ultimately, this is about making local confidential computing operational, repeatable, and trustworthy. You can Azure Local devices in the Azure Local catalog from OEMs, our partner OEMs, such as currently we're working with Lenovo, HPE, Primeline. You can get those devices today. You can try the private preview for CVMs on Azure Local with AMD Genova. And we're working to expand both additional silicon partners and OEM partners. Any other thoughts, David?
Azure Local is here now. Like you said, private preview, public previews eventually coming out. I can't speak to that officially. But a lot of good stuff that we've been doing with this. As we said, everything that you got deployable in CVMs right now in Azure is coming on-prem. It's super exciting to see what we've done with this. Appreciate the partnership with Microsoft on this. I've been pushing Deepak to get this thing out to market as quickly as possible. Like I said, we've been working on SEV solutions. The boring thing about this whole thing is, as we've talked about this being kind of the year, 5 years from now, this is going to probably all be default. Standard VMs of today will all be confidential VMs. It's just a matter of teaching the ecosystem and making sure how to deploy these and making sure everybody can have their trust and attestation processes in place. So it's amazing what we're doing today, but it's even more amazing where we're going with some of this technology in the future.
We'll have some time for questions. Happy to take any questions. Oh, go ahead. Sorry. Sorry, I didn't hear your question.
What are the two types of virtualization? The hybrid, and now also company which is executed on the Microsoft Thread. But you don't want to how to isolate that.
You want to isolate the
WSL2.
Can you repeat,
W-
Deepak, can you repeat the
WSL?
question?
Oh, okay. So, okay, the question was. Uh-huh. Uh-huh. Yeah, I think the question was about WSL and like needing to isolate. So yeah, that's a good question. I think that's a little bit outside of the Azure Local space. That is more in the Windows 11 space where we have WSL. That's a good question. I'll definitely follow up offline. And here, in the context of this talk, I think we're talking about Azure Local. Definitely will follow up offline. Yeah.
I couldn't understand what are the solutions for the attestation verification.
So
is it already there? Is it planned?
yeah. So question was, what are the attestation solutions that work disconnected? So today the reason why we're doing this OS integrity because it allows us to take a measurement of the attestation at boot time, and it retains that measurement during the boot lifecycle of the VM. In the future, for continuous measurements of attestation, even during the lifecycle, we're looking at an offline attestation service, which will run. The SKR, we are looking at bringing that offline. Yeah. And there's certain sort of like, I think previous talk talked about like how you got to bootstrap it with a cryptographic key, etc. So yeah, we're working on that.
Obviously, the QR code, you can see the certified solutions. Another one is a resource from the AMD side is developer.amd.com/SEV. I know that's a lot of words, but it goes into a lot of the hardware specifics as well. I mean, the hardware is kind of the boring part once you get past what you guys are doing from the Azure Local and the software solutions. If you have any other questions here, please come up or find us in the hallway. Thanks for your attendance.